Hello class, welcome to our session for today. We're going to solve the next problem, a sample problem from physics. So this is our problem number 4. Rocket-powered sleds are used to test the human response to acceleration. If a rocket-powered sled is accelerated to a speed of 444 meters per second in 1.83 seconds, then what is the acceleration and what is the distance that the sled travels? Okay, so like in our previous examples, so let us write down first the givens. So this problem gives us the following. We have 400 meters per second. So accelerated to a speed. So this is the speed or the velocity v equal to 444 meter per second. And we have 1.83 seconds. So it means that we're given the time that is 1.83 seconds. And this problem asks us to solve for the following. So what is the acceleration? Okay, what is the acceleration? So A is need to be found. And what else? What is the distance? So what is the distance that the sled travels? So it means we have to find also the displacement. Okay, so to show some illustration, so assuming that the sled is not yet moving, so it means at this point, assuming that the sled is at this point, so this is at t equal to 0. So at this point means that the sled is not yet moving at equal to 0. So if there's no movement yet, so therefore we can say that the initial velocity is also equal to 0. Then after at time t equal to 1.83 seconds, so what is the acceleration? So it's given that the rocket-powered sled accelerated to a speed. So the speed here is 444 meters per second. And this is the displacement, the distance traveled by the sled. Alright, so writing down the formulas. So we have final velocity v equal to the initial velocity v sub 0 plus the acceleration times the time. And we also have the displacement S equal to initial velocity multiplied by the time t, then plus 1/2 a times t squared. Acceleration in the time, square the time. And the final velocity squared equal to the square of the initial velocity plus twice the product of the acceleration and the displacement or position. So which formula that we can use first? So at t equal to 0, v sub 0 equal to 0. So final velocity v is given. This is 0. Then we can solve for a because t is given. So from here, so from this formula, v equal to v sub 0 plus a times t. Our v is 444 equal to initial velocity is 0 plus the acceleration, then time, that is 1.83. Okay, so from this resulting expression or equation, so we can solve for a. So 1.83, this one multiplied by a equal to 444. And solving for a, divide both sides by 1.83. So we have a equal to, so divide both sides by 1.83. So a is equal to how much? 242. Okay, so we have 444 divided by 1.83 is equal to 242.6 or 62. So what is the unit? So acceleration means, so we're given the displacement in terms of meters and this acceleration, so we're given velocity, that is meter per second, then we have time in second, so meter per second, or this is simply meter per second squared. Alright, so this is the acceleration asked in the problem. Next, we are asked to solve for the displacement. So in solving for the displacement, we have two formulas that we can use. We can use either this number 2 formula or the third formula. So from the second formula, S equal to v sub 0 times t plus 1/2 at squared. Substituting, so v sub 0 is equal to 0, so the whole thing here is, the first term is equal to 0. So we have S equal to 1/2 times A. Our A is 242.6, then multiplied by the time, that is 1.83 squared. So S is equal to, so what is our S equal to? So 1.83 squared. So squared means you just times it by 1.83 also. Then times 242.6 times 1/2 or 0.5. So this is equal to 406.2 or 0.3. Now if you take all the decimal points, so it will give us the exact value here is 406.26. Okay, so what is the unit? The unit is in terms of meters. Alright, so this is the result, no, using the second formula. Or you can use the third formula. So using this third formula, so v squared equal to v sub 0 squared plus 2as. And we know that the initial velocity is equal to 0. So this part here is equal to 0. So v squared is equal to 2 times as. So solving for s, so divide both sides by 2a. So therefore s is equal to v squared over 2 times a. Then substituting the given, we have 444, then squaring this one, divided by 2 times our a is 242.6. You can take all the decimal after this 0.6 here, not to get the exact value. So therefore s is equal to so 444 square, just times 444, then divided by 2 times 242.6. Sorry, we have to use the scientific calculator here. Okay, so 444, you square this one, then divided by the quantity, 2 times 242. 242.62 or 2.6. So it gives us 406.26. Now if you take the exact number class, so it will give us the same result as this. So 406.26. So this is also in meters. Okay, so any of the formula will give us the same result. So you may use 2 decimal points or 1 decimal point. Alright, so thank you very much and see you again in our next example. So bye for now.